Finding fractions of a number. Let's say we have 12 pizzas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we want to know how many would 3/4 of these pizzas be? 3/4 of 12. Well, first of all, it would be a good idea to find 1/4. And to find 1/4 of 12, we have to divide our pizzas equally into 4 parts. And you know that 4 goes into 12 3 times. So if you divide this equally into 4 parts, each part will have 3 pizzas. So 1/4 of 12 is 3. So what do you think 3/4 are? Well, you're going to have 3 lots of these groups. 1, 2, 3. So altogether, they're going to be 9. So 3/4 of 12 equals 9 pizzas. In it with another example, let's see what you think 2/5 of 20 is. We'll find 1/5 first. 1/5 of 20 means you divide 20 by 5. 1/5 of 20 equals 4. But you don't have 1/5, you have 2/5 they want to know. Well, 2/5 is going to be twice that amount. So 2/5 is going to be 8. So basically what you do is you divide by the bottom, then you times by the top. You divide your number by the denominator, then you times by the numerator. So let's see, let's do 3/7 of 49. Right, so if you remember what I said, we divide by the bottom first, and that which equals 7, because 7 into 49 is 7. Then we times by the top. 7 times 3 is 21. So 3/7 of 49 is 21. You must remember though that the word of can be substituted with the times sign, the multiplying sign. So our 3/4 of 12 can also be written as 3/4 times 12 over 1. And that's because any whole number as a fraction has a denominator of 1. These are the same. 3/4 times 12 is the same as 3/4 of 12. Now let me show you a method called cross-cancelling to do this. Well, before we cross-cancel, the rule for multiplying fractions is you can do the numerator times the numerator over the denominator times the denominator, and then simplify. So 3 times 12 is 36. 36/4. Now remember, this line also means divide. 36/4 is the same as 36 divided by 4, which equals 9. And that is the same answer, of course, as when we did 1/4 of 12, which is 3, and then times it by 3, which is 9. This is another method of doing fractions of a number. You can change the word of when it's fractions to a times sign. And the reason we learn this is because if you were asked the following question, what is 3/4 of, which I'm going to turn to times, 3/4 of 6/9, then that's difficult to do as 1/4 then 3/4 because it's of a fraction. So that's when we would multiply. Instead of writing of, same as of, you can write of there. We change it to a times sign, and then we do the numerator times the numerator over the denominator times the denominator, then you can simplify. So that equals 18 over 36. And to simplify that, they can both be divided by 18. 18 goes into 18 once. 18 goes into 36 two times. So actually 3/4 of 6/9, or 3/4 times 6/9, is actually the same as a half. Now the last stage I want you to talk about is cross-cancelling. Let's do 3/4 times 6/9 again. We've got 3/4 times 6/9. Now instead of, you can of course, as I've said, multiply numerator by the numerator, denominator by the denominator, and then simplify your answer. But another way of doing it is we can simplify this first before we multiply. And the rule is you can simplify any numerator with any denominator. It doesn't have to be the same fraction. I could simplify this numerator with that denominator, or this numerator with that denominator, and that's called cross-cancelling. Now we know from the last page that the answer is going to be a half, so let's see if this theory works. Right, I'm going to simplify this numerator with this denominator. 3 goes into 3 once, 3 goes into 9 3 times. I can also simplify this because they're both divisible by 2. 2 goes into 4 2 times, 2 goes into 6 3 times. Now I can't simplify any further, so now we multiply. Numerator by numerator, 1 times 3 is 3. Oh, I could have simplified somewhere else. There's a 3 there and a 3 there. 3 goes into 3 once. 3 goes into 3 once. They can be simplified. Now we can multiply. Numerator times numerator over denominator times denominator. 1 times 1 is 1, over 2 times 1 is 2, a half. Now you saw that I had missed this, simplify, but that wouldn't have mattered. I could have done 1 times 3 is 3 over 2 times 3 is 6, and then you know to simplify 3/6 to 1/2. So that's a beauty with all of this. There's so many ways of doing it. As long as you simplify each step, you'll get to the same answer. Let's do one more. I'm going to deliberately choose numbers that can be simplified or cross-cancelled. So if I put a 3 here and a 9 here, and I put a 10 here, and a, let's say 5 here. So they're asking what's 3/10 times 5/9, or 3/10 of 5/9. Well, I could choose just to multiply my numerator by numerator, which is 15, over my denominator times denominator, which is 90, and write 15/90ths, then simplify. But I'm trying to teach you cross-cancelling here. So is there any numerator and any denominator you can simplify? Yes. 5 goes into 5 once, 5 goes into 10 2 times, 3 goes into 3 once, 3 goes into 9 3 times. So we'll still get the same answer because it's multiplying, and multiplying works both directions. We can simplify crossing, that's why. I've simplified as far as I can, so now it's numerator times numerator, which is 1, over denominator times denominator, which is 2 times 3, which is 6. So 3/10 times 5/9 is 1/6. And if you chose not to cross-cancel first, you would have had 3/10 times 5/9 would have given you 15/90ths. And then you have to simplify it in stages. They can both be divided by 5. 15 divided by 5 is 3. 90 divided by 5 is 18. Then I can see they can both be divided by 3. 3 goes into 3 once. 3 goes into 18 6 times. So you get the same answer. But by simplifying, by cross-cancelling first, it made your multiplying easier instead of all these steps.